Here we go.
All right, cool. Yeah, we have this fake mesh that I built out for this experiment. We can delete this so we can see the whole thing from the beginning. But essentially you have virtual services, virtual routers, and virtual nodes. The service, each of our R101 apps will have a virtual service. So I created an Acme Inc. service. And then if you click into that, each service has a router and routes. And right now, you can do all sorts of fancy things. But right now what I'm saying is send all like HTTP requests to the same virtual node. But you could actually like split out like certain paths go to certain other hosts. So it almost acts kind of like an API gateway in a way. But for now, really dumb. We just have a single virtual node that's getting 100% of the traffic. Like later on when we do a test, we could have like 2 different deployments of Acme Inc. Have one of them return one value and have another one return another value. And then we could test out like how we would do a release, which is like we could have the weights get modified and it would only get a certain amount of traffic and stuff. So you have services, you have routers and routes, and then you have virtual nodes. The virtual nodes are where the service discovery comes in, where right now it's pointed at this fake record that doesn't actually exist because I just wanted to get it done. But what we need to do is we need to get Stacker to create ECS tasks with service discovery instead of with ELBs. And if we can get that done, then this will be an actual DNS record inside of Route 53. And then it'll automatically, when we hit the main mesh, it'll automatically flow through and hit Envoy, and then hit the service that's upstream from Envoy. One thing that's really wild is I was looking at, you can tell where was it? I forget where it was. You can tell, let me edit one of these. So sorry about that noise. I should leave. I'm gonna quit Slack. Okay. So virtual router. So I'm gonna edit the virtual router. So it's just listening on port 80, which the virtual router is essentially what port Envoy will listen to, I think. So we could choose any port we want. I'm not sure if 80 is the right port or not. So let me edit virtual service. And you can see the provider. So I forget where I was, but I was able to tell it, let's just create a new mesh together. Okay, so here's one thing. You can say that this mesh, the instances or the containers in the mesh are not allowed to go to the internet, which is not something we want. I think all of our services kind of expect to be able to hit third parties over the internet. So we'll have to allow it. Actually, let's go to the get started. This is how I built it. I use this tool. So this gives you, when you go to the get started, it gives you description of each thing. So you have like the meshes, virtual services, virtual nodes, routers, and routes. And then here, this gave me a hint as to how it works and that it actually does use Envoy right there. So that's cool. And it needs ECS, which we already have, which is cool. We need to modify the app. That's something we'll do today. And then the reference of the ARN of the service in deployment. So let's allow external traffic, and we'll call this mesh or dev mesh 1. And then the virtual service, I'm not sure what this, I'm pretty sure this is supposed to be something like Acme Inc. or like SFTP or something. Like that's what that feels like it would be named after. But I might be wrong. But my guess is it would be something like dev Acme Inc. And of course, we're going to need to make Stacker do this, but for now, we'll do it here. Virtual node. This is where we need to get service discovery to work because we want to tell it, we would give it a name, but we would give it the DNS record of the service discovery for that ECS service. And if we go to the cluster and we go to this here, it currently has an associated load balancer, or it doesn't have the service discovery. Typically, when you have service discovery, it would show up on this page here, which it's not. So we need to modify that, I believe. And that essentially is just the DNS record that would go in here. And you notice that it's at the service level, not at the task level. So it's like doing routing for us, which is pretty cool. Yeah, and then, so we can call this app. We can call this, what is it? Acme Inc. Dev.
So no, I know I'm oversimplifying, but so looks like App Mesh is a mixture of R1 router and ELBs. That would be like a place.
Yeah, you can build it in two ways. It would be like the edge proxy would, if we built out App Mesh, like we don't have to, we can continue to use router. But when the time comes for, if we wanted to, we could essentially use App Mesh for that as well.
Okay. So
yeah,
but takes that place in a conflict in arbitrary.
But for our purposes, like our MVP or our minimal version of the app, or this change would be just for the internal services.
But so it kind of does the job that R1 router does. I mean, that's
yeah, and the ELBs.
And ELBs, of course. Not ECS.
But not ECS. We still use ECS.
Works with ECS, okay.
Yep, and also works with Kubernetes. In fact, Lyft uses Kubernetes, and Lyft is the one who created Envoy, so.
Yes, sorry for the interruption. I'm trying to make a mental model.
No, it's great because I literally learned this like yesterday when I had the aha moment. I was like, oh, so I don't have to change the whole paradigm. I'm just adding to it. So once we get service discovery working, we have a value to be here. But for now, I'll just put something silly like test.com. Hostname must be fully qualified. And then ports. I'm not sure like what ports go where yet, but let's just say it ran on 8080. And then finally the router. You can actually have the router or the route like check things on the application layer. So
like NGX, okay.
Yeah, like headers. But you could also have it do things at the other layers for networking, which is pretty cool. Virtual node, route type, route priority. So this would be dev Acme Inc. vRouter. And I don't know what naming convention we're going to use yet, but let's just say this is going to be 80. And the name, we'll just call it root for now. Priority is 1. And and we'll match everything. So slash, I guess. Yeah. Slash matches all. And hit next. And then it just gives you an overview. Create mesh. It takes a little while for it to create stuff, I think. I don't know. It's pretty quick. One thing that I saw is the mesh also takes, it also has this kind of concept of security groups where you have to explicitly say R101 API is allowed to talk to Hermes, for example.
Gotcha.
If you don't, it won't be able to get there, which is really cool.
Yeah, that's what we could make in router, for example. Well,
right. Well, we can't do that with router. We'd have to do it with security groups, right?
That's more like the ELB part, yeah. So it's
yeah. It'd be like, yeah, it would be like the security groups on an ELB. We would have to
there you go.
Make those smart, and that's kind of a hard problem. AppMesh kind of solves that for us. I wasn't that's what I wanted to show you guys, but I wasn't sure where it went because I did see it.
No, yeah, but it makes sense because I think I'm figuring out what it does, what AppMesh does.
Yeah, it's essentially like a mesh network.
So what you just created is kind of an endpoint where you could send traffic, and that endpoint would have smart rules for sending into services, which would be ECS services if we want to. Mm-hmm. The only requirement for them is to include Envoy.
Yes.
So, I mean, of course, simplifying a lot.
Yep, that's it exactly. That's exactly it. Okay. Then the things that Envoy unlock are kind of crazy. So I was watching a talk yesterday where they were showing how, like you have monitoring and you have logging and you have tracing for all these different languages, and they don't always use the same. They don't always do it the same way. Okay. And so part of the reason why Lyft created that was because they have so many different languages at their company, and even the same. Like even Datadog, like if you use Datadog on a Ruby app versus a Python app, you're going to get slightly different things.
Yeah.
So when they created Envoy, they had this consistent layer for logging, for tracing, and for metrics that work for any upstream language. So it's consistent in that way. So you'll always get the same sort of latency metrics. You'll get the same sort of load and everything. So that's one huge benefit, is like the observability of it. And then the fact that it gives you all these other like flexible routes and stuff makes it a lot more powerful as well. But yeah, that's kind of all I learned so far. The rest is like up for us to figure out what to do.